Hello friends, welcome to my second lecture on transportation problem. In the previous lecture on transportation problem, we had considered two methods. They are north west corner rule, and then the second one was least cost method to determine the basic feasible solution for the transportation problem. Now we have third method, which is known as Vogel's approximation method or unit cost penalty method. So, this method is most effective method to find basic feasible solution. Let us discuss this method. So, in this method we first step is to identify the smallest and next to smallest cost for each row of the transportation table. So, we prepare the transportation, we have the transportation table, we will identify the smallest and next to smallest cost for each row of the transportation table, and then we find the difference between them for each row. We write these differences alongside the transportation table against the respective rows by enclosing them in parentheses. We write similar differences for each column below the corresponding column. They are called penalties. Okay. These differences are known as penalties. Now, we select the row or column for which the penalty is the largest. So, we inspect all values, the differences which we found for rows and the differences which we found for penalties, we found for columns. Okay. That is, we inspect all the penalties. Then we identify the penalty which is the largest. If a tie occurs, we use any arbitrary tie breaking choice. We can suppose there is a tie between two penalties, when both penalties are same and they are largest, then we can choose either one, either penalty to begin with. Now, allocate the maximum possible amount to the cell with lowest cost in that particular row or column. So, we identify the penalty which is the largest, then in that particular row we identify the column which is the which has the lowest cost. So, in that column, in that cell we allocate the maximum possible amount. Okay, and maximum possible amount, suppose the maximum penalty occurs in the ith row, for example. Okay, maximum possible the penalty occurs in the ith row, then and the lowest cost cell is the cell where the cost is Cij. Okay. So, then to that cell which is having lowest cost Cij, we shall allocate the maximum possible amount, that is the minimum of Ai, the Ai and Bj, where Ais are the amounts which are available. Okay, in that row, and then the Bj is the maximum demand. Okay, the demand for that. So, Ai Bj, we will take the minimum value of that. So, let the largest penalty correspond to ith row, largest penalty corresponds to the ith row, and Cij be the smallest cost in the ith row. Then we allocate the amount Ai Xij, which is minimum of Aij, Ai and comma Bj in the cell Ij. Then we cross out the ith row, or if it occurs in the jth column, maximum penalty occurs in the jth column. Okay, then we cross out the jth column. Okay, in the usual manner, and construct the reduced matrix. So, in the second third step, we compute the row and column penalties for the reduced transportation table, because we have deleted the ith row or the jth column. Now, we have the reduced transportation table. So, we again calculate the penalties and then identify the row or the column which has got the maximum penalty. Okay, and in that row or column we then identify the cell which has got the lowest cost. Okay, which has got the lowest cost, and in that we allocate the amount Xij, which is the minimum of Ai comma Bj for that cell. Okay. So, we continue this process until all the available quantity is exhausted or all the requirement is satisfied. Now, let us see, this is our transportation table, the cost and requirement matrix. Okay, this is our cost and requirement matrix. In the parenthesis you see we have the cost for each cell. 2 is the cost for this cell, 7 is the cost for this cell, 4 is the cost here, and 3 and 3 1 they are cost in this row, 5 4 7 are the cost in third row, and 1 6 2 are the cost in the fourth row. And with F1, F2, F3, F4, 5 8 7 14 units are available, and the requirement at the warehouse W1, W2, W3 are 7 9 and 18. Okay. So, let us first identify let us first find the penalties. Okay. So, we how to find the penalties? Let us go to this. We find the difference between the smallest and next to smallest cost for each row. Okay. So, here smallest is what? Let us take this first row. Okay. Smallest is 2 and next to smallest is 4. Okay. So, the difference is 2. Okay. So, we write this 2 in the bracket. In the second row smallest is 1, next to smallest is 3. Okay. So, the difference is 2. In the third row smallest is 4, next to smallest is 5, and the difference is 1. So, we write 1 here in the bracket, and then here smallest is 1, next to smallest is 2, the difference is 1. So, we write 1 here. Now, let us consider. So, we have found the penalties for all the 4 rows. For first row it is 2, second row it is 2, third row it is 1, fourth row it is 1. Now, for the first column what is the penalty? So, least number, I mean the least cost is 1. Okay. And then the next to smallest is 2. So, difference is 1. Okay. So, we have 1 here. Here the smallest is 3. Okay. Next to smallest is 4. So, again the difference is 1. Here smallest is 1. Next to smallest is 2. So, again the difference is 1. So, the penalties row wise are 2 2 1 1 and column wise they are 1 1 1. Now, let us find the maximum penalty. Okay. So, maximum penalty occurs along first and second rows. Maximum penalty is 2. Okay, and it is occurring along first row and second row. So, there is a tie. Okay. There is a tie. So, we have to break this tie. We can select either first row or second row to begin with. Suppose we select the first row. Okay. So, select the first row. Okay. Now, then we will find the cell in the first row which has got the lowest cost. So, this cell, okay, this cell had got the lowest cost, and lowest cost is 2. Okay. So, so the lowest cost cell is cell is 1 1. Okay. And the cost and the lowest cost is 2. So, to this cell which has got the lowest cost, we give the maximum possible amount. Okay. Now, with F1 5 units are available and the requirement of W is 7. So, we can allocate minimum of 5 and 7, that is 5. Okay. So, allocate 5 here, okay, to this cell. Okay. Now, we then cross out first row. Okay. After we have allocated 5, okay, we have F1, the capacity of F1 is exhausted. F1 we have delivered all 5 units available with F1 to the warehouse W1. Okay. So, 5 is, so we will cross out the first row, and then we will have 3 rows, okay, second, third and fourth row, and then 3 columns. So, the next transportation table is this one. Okay. So, 3 3 1 5 4 7 1 6 2, that is the next table after we have deleted the first row, removed the first row. Okay. Again we calculate the penalties. Okay. So, here the lowest cost is 1, the next to lowest next to smallest is 3. So, the difference is 2. Okay. Here lowest cost is 4, next to lowest is 5. Okay. So, we have difference 1, here smallest cost is 1, next to smallest is 2. So, we have difference 1. So, column wise now let us find the penalties. So, smallest is 1, next to smallest is 3. So, difference is 2, smallest is 3 here, next to smallest is 4. So, difference is 1 here, smallest is 1 here, next to smallest is 2. So, difference is 1 here. So, now let us find again the maximum penalty. Maximum penalty is 2, and it occurs in the first row and the first column. Okay. So, it occurs in the first row and first column. So, we can select either the first row or we can select the first column. So, let us select first column. Okay. Now, then we will identify the cell which has got the lowest cost. Okay. So, this cell has got the lowest cost, and to this cell we shall allocate the maximum possible amount that is available. Okay. So, we have with F2 we are 8 units are available and the requirement of W3 is 18. So, we can allocate maximum possible amount with F2, that is 8. So, minimum of 8 and 18, that is 8. So, we can allocate 8 to W3. Now, we have allocated all the available units with F2 have been allocated. So, we will cross out the second row and then we shall have the remaining 2 rows 5, 4, 7, 1, 6, 2. So, that will be our next transportation table. So, this is our next transportation table 5, 4, 7, 1, 6, 2. Okay. We will again find the penalties. Okay. So, penalties now are least lowest smallest cost is 4, next to smallest is 5. So, difference is 1, smallest cost here is 2, next to smallest is smallest cost is 1, next to smallest is 2. So, difference is 1, and column wise 1 is here, 5 is there. Okay. So, smallest is 1, next to smallest is 5. So, difference is 4, and here smallest is 4, next to smallest is 6. So, difference is 2 here. Here the difference between smallest and next to smallest is 5. Okay. So, maximum penalty is now 5. Okay. And it occurs along the third column. Okay. It occurs along the third column. So, let us now find the cell which has got the lowest cost, and this cell has got the lowest cost too. Okay. So, we allocate the minimum of 14 and 10. Okay. So, 10 units are allocated to the cell with the cost 2. Okay. Now, what is left with us here? So, we have allocated 10. So, we have so then after that we cross out this cell. Okay, because we have already allocated the capacity of W3 is now exhausted. W3 was requirement was 10. Okay, and we have allocated 10 units to W3. So, third column is now removed, and we have the transportation table containing 2 rows, this one 5, 4, 1 and 1, 6 and 2 columns. So, this one 5, 4 and 1, 6. So, this is now reduces, this transportation table reduces to this one, this is W1, this is W2, this is F3, F4. Okay. All right. Now, we go to next table then. Okay. So, out of 14, 10 have been given. So, this is now reduced to 4. Okay. F4 has now 4 units available. Okay, and F3 has 7. Okay. And here this is 2, this is W2 29. Okay. So, 29. Okay. So, we have this transportation table. So, let us go to this one. Okay. Now, we can see again the lowest cost is 4 and next to lowest is 5. So, the difference is 1. Here is next the smallest cost is 1, next to smallest is 6. So, the difference is 5. Here the smallest is 1, next to smallest is 5. So, difference is 4, here smallest is 4, next to smallest is 6, so difference is 2. Okay. So, what is the maximum penalty? Maximum penalty is 5. It occurs along the second row. Okay. So, let us identify the column, the cell which has the least which has the lowest cost. So, this cell has got the lowest cost 1. So, we will then give it to allocate minimum of 2 and 7, that is 2. So, we allocate 2 to this cell. Okay. Now, the requirement of W1 was 2, okay, and we have allocated 2 units to W1. So, we can cross out this column, okay, we can cross out this column, and then what are we left with? F3, F4. Okay. So, we have from 4 we have given 2, no, we are taking minimum of 2 and we are giving 2 minimum of 2 and 2, why 2 and 7? Maximum penalty was 5, okay, and this cost, this cell has got the lowest cost 1. Okay. So, we take the requirement of W1 is 2 and the availability of W with the F4 is 4. So, minimum of 2 and 4 we have to take. Okay. So, we allocate 2 here. So, then the requirement of W1 is fulfilled. Okay. We can cross out W1 and with the F4 now 2 units are available. Okay. F4 2 units are available, okay, and F3 has got 7. Okay. F3 has got 7 requirement, the available units with F3 are 7 and the total requirement of W2 is 9. Okay. So, we allocate 7 to F3, F3 is this has got cost 4. So, we allocate 7 to this and we allocate 6 to this, okay, and we cross out. Okay. So, this is what we do. Okay. So, we had only 7 units available with F3 which we have given to W2 where the cost is 4, okay, and we have given 2 units to W2 where the cost is 2. Okay. So, ultimately we have this table, okay. 5 from F1 source we have given all 5 to W1, okay, with cost 2, and if we summarize, then we have given 8 all the 8 which was available with F2 to W3, and we have given out of 7 7 to W2, okay, with cost 4, and then we have given out of 14 which was available with the 4 2 to W1, 2 to W2 and 10 to W3. This we can see from here. See, we can begin from here. This was the losses. Okay. So, we gave 5 from F1 to W1, okay, 5 from F1 to W1. We gave out of 8 all 8 to W3, okay, and we have given from F3 from F4 we have given out of 14 10 to W3, and then we have given out of 7 which was available with F3 to W2 with cost 4, 2 to W1 have been given from F4 and 2 to W2 have been given from F4. Okay. So, this is what we have this is how we have allocated the units that were available with F1, F2, F3 to the warehouses W1, W2, W3, W4. Now, we can calculate. So, this is the VSF, okay, which we have got, and then the total transportation cost is 5 into 2, okay, then 8 into 1, then 7 into 4, then 2 into 1, 2 into 6 and then 10 into 2. So, that is 80 rupees. So, that is the transportation cost which we have got by the Bogle approximation method. Now, let us discuss optimality test. After getting the initial feasible solution, okay, of the transportation problem, we then find this we then test this solution for optimality. Okay. Let us test this solution for optimality. We check whether the feasible solution obtained minimize the total transportation cost are not. Okay. Therefore, the optimality test to a feasible solution consisting of n plus n minus 1 allocations. You can see how many allocations we have made. You see 1, 2, 3, 4, 5, 6 allocations we have made, and m plus n, there are 4 rows and 3 columns. So, m is equal to 4 and n is equal to 3. So, m plus n minus 1 equal to 6. Okay. So, we have made 6 allocations. Okay. So, let us test whether this solution which we have got, this one, this solution is optimal or not, and if it is not, we will improve this to get the optimal allocation. Okay. So, therefore, the optimality test to a feasible solution consisting of m plus n minus 1 allocations in independent position, that is to a because when there are m plus n minus 1 allocations in independent positions, we get non degenerated BFS. Okay. So, we will discuss this method, MODI method, okay, or we also call it as UB method, to test the optimality of the solution which we have got from Bogle approximation method. Okay. So, for the solution of a minimization transportation problem, let us proceed systematically as follows. Okay. The iterative procedure of determining an optimum solution of a minimization transport problem is known as MODI method. Now, let us first we construct a transportation table entering the capacities A1, A2, AM, A1, A2, AM are the capacities of the sources F1, F2, Fm, and the requirements B1, B2, Bn, they are the requirements of the n warehouses W1, W2, Wn. Now, we enter the various costs Cij at the upper left corner. So, we have to follow a system of allocation on writing values in the various cells. We will write the cost Cij of in each cell at the upper left corner. Okay. Find an initial BFS, that is allocation in independent positions, okay, and then enter the allocations at the center of the cells. So, the problem just now we have solved. Okay. In that problem, the allocations that we have made, they will be written in the center of the cell, okay, and the cost Cij of each cell will be written in the upper left corner. Now, let us find the set of numbers ui and bj. Ui runs from 1 to m, j runs from 1 to n, okay, such that for each occupied cell means the cell which has been where the allocation has been made, okay, and non-occupied cell means this cell where no allocation has been made. Okay. So, such that for each occupied cell Rs, okay, Crs equal to Ur plus Bs. Crs is the cost of the Rs cell. Okay. So, Crs equal to Ur plus Bs. Now, find Ui plus Bj for each unoccupied cell. Okay. For each unoccupied cell or the cell where the no allocation has been made. So, for each such cell we have to find Ui plus Bj and enter at the upper right corner of the corresponding cell Ij. Okay. So, Ui plus Bj we shall find, and Ui and Bj we shall find, and Ui plus Bj we shall enter at the upper right corner. Okay. Now, then we will find the cell evaluations Dij equal to Cij minus Ui plus Bj. Cij is the entry in the ijth cell at the upper left corner, and Ui plus Bj is the entry at the upper right corner. So, we will find the difference of Cij and Ui plus Bj for each unoccupied cell, okay, and enter at the lower right corner of the corresponding cell. Okay. So, the values of Dij will be found for each unoccupied cell, and the values of Dij will be written at the lower right corner of the unoccupied cell. Now, we will examine the cell evaluations Dij, okay, for all unoccupied cells. If it happens that all Dij are greater than 0, okay, Dij is greater than 0 for every unoccupied cell, then the solution under test is optimal, okay, and unique. Okay. So, we have found the unique optimal solution if Dij turns out to be greater than 0 for all I and j, and they belong to unoccupied cells. Now, if Dij is greater than or equal to 0 with at least one Dij equal to 0, okay, then the solution under test is optimal and alternative optimal solution exists. Okay. So, solution under test is optimal, but it is not unique. alternative optimal solution exists. Now, if at least one Dij is less than 0, suppose there is one Dij, at least one, which is less than 0, then the solution is not optimal and we have to proceed to the step 6, okay, this step 6. So, we from a new BFS, okay, by giving maximum allocation to the cell for which Dij is minimum, okay, we will form a new BFS, okay, by giving maximum allocation to the cell for which Dij is minimum and negative. Okay. So, this step 6 will go to step 6 if there is at least one Dij with negative value, okay, less than 0. Okay. So, maximum allocation will be made to the cell for which Dij is minimum and negative. Okay. So, we will take that Dij which is minimum and negative by making an occupied cell empty. An occupied cell will be made empty and the allocation will be made to this cell, maximum allocation will be made to this cell, okay, where Dij is minimum and negative. Now, then we will repeat steps 2 to 5, okay, 2 to 5 means these steps, okay, we will repeat these steps again, okay, this 2, 3, 4 and 5, these steps will be repeated, okay, and then we will again test the optimality, that is we will again check the value of Dij. Okay. We will continue to improve this BFS, okay, using this step 2 to 6 till an optimal solution is attained. Thus, in the table after making all the entries, the occupied cell, that is cell having allocations, okay, and the unoccupied cells will be as follows. Let us see. So, this is our first table where Cij's are the cost of the ijth cell, they are written in upper left corner. Okay. So, allocations are there in this table. Okay. Now, this ui plus bj, they are the values, ui plus bj is the value sum of ui and bj, which is written in each unoccupied cell, upper right corner. Okay. So, upper right corner it is written, and in the lower right corner we are writing Dij equal to Cij minus ui plus bj, and we have to check the sign of Dij for the optimality. So, say for example, we have this table, okay, this table is given, we are having 4 sources, 1, 2, 3, 4 sources and 3 warehouses, 1, 2, 3, and the availability with the 4 sources is 5, 8, 7, 14, and the demand at warehouse 1, 2, 3 are 7, 9 and 18. Okay. Total is 34. So, it is a valence transportation problem. Now, we have got its solution of this problem we have already got by Bogle approximation method, and we have seen the allocations that have been made to the cells here. So, let us use that initial BFS, okay, by BAM method, Bogle approximation method. So, when we applied Bogle approximation method, we got the allocation 5 to the cell with cost 2, this is cell 1 1, okay, and then we allocated 8 to this cell with cost 1, that is second row and third column. Okay. We allocated 7, okay, units to the column with cost 4, to the cell with cost 4, it is third row and second column cell, okay, 3 2 column, 3 2 cell, okay, and then we have allocated out of 14 that were available with source 4, 2 we allocated to the cell which lies at third row and first column, 2 units to the cell which lies at fourth row and second column. So, this is 4 1th position, 4 1th position, this 4 1th cell, this is 4 2th cell, this is 4 3 cell, okay, cell 4 1, cell 4 2, cell 4 3. So, 4 1, 4 2, 4 3 have been given 2 2 and 10 units out of 14. So, this allocation we have made by BAM method. Okay. So, we will use this allocation and see whether the solution that we have got, this solution is optimal or not. Okay. So, let us find ui and bj, okay, ui and bj such that for each occupied cell Rs, CRS equal to ur plus Bs. Now, we have to choose this U4, okay, U4 we have to choose. So, U4 see, let us inspect all rows and columns, okay, which have got various allocations. First row has got allocation of 5 units, second row has got allocation of 8 units, third row has got allocation of 7 units, and fourth row has got allocation of 14 units. So, the row that has got the maximum allocation, that we have to consider. So, this fourth row has got the maximum allocation. So, we will consider u 4 equal to 0. In fact, if suppose ith row has got the maximum allocation, we shall consider u I equal to 0. So, here fourth row has got the maximum allocation. So, we consider u 4 equal to 0. Row 4 contains maximum number of allocations. So, we take u 4 equal to 0. Now, making use of CRS equal to u r plus b s, CRS equal to u r plus b s. You see, this cell has got 2 units, okay. This cell has got units. So, this is occupied cell, okay. For each occupied cell, CRS should be equal to u r plus b s. So, this is C 4 1 equal to u 4 plus b 1, we have C 4 1, okay, C 4 1 equal to u 4 plus b 1, and C 4 2 will be equal to u 4 plus b 2, C 4 3 equal to u 4 plus b 3. C 4 1 is equal to 1, you see, cost is 1, okay. C 4 2 is 6, C 4 3 is 2, okay. So, we have this gives you C 4 1 is 1 equal to u 4 plus b 1, but u 4 is equal to 0. So, we get b 1 equal to 1, okay. Then C 4 2 is 6. So, this gives you 6 equal to u 4 plus b 2, and this is equal to 0 plus b 2. So, we get b 2 equal to 6, and then C 4 3 is 2, okay. So, 2 equal to u 4 plus b 3. So, we get b 3 equal to 2, okay. Now, so we got the values of b 1, b 2, b 3, okay. Now, we other cells which are occupied are C 1 1, C 1 has been allotted 5 units, okay. So, C 1 1, so C 1 1 the cost of associated with C 1 1, C 1 1 is equal to 2, right. So, we have C 1 1 equal to 2. So, 2 equal to u 1 plus b 1, C 1 1 equal to u 1 plus b 1. So, and b 1 is equal to how much? B 1 equal to 1, okay. So, u 1 plus 1. So, this gives u 1 equal to 1, okay. We got u 1 equal to 1 here, and then we other occupied cells are let us see. So, this cell, okay, this cell we have, which this cell we can see we have this is third row second column, okay, third row second column. So, we have okay, let us go to this one, okay. After first row we go to second row, okay. So, C this is second row third column. So, C 2 3, the C 2 3 is equal to 1, okay, 1 equal to u 2 plus b 3, okay, and b 3 is equal to 2, okay. So, we get u 2 plus 2. So, we get u 2 equal to minus 1, okay. So, we get u 2 equal to minus 1 here, and then third one is this 7, okay. So, this is third row second column. So, third row second column. So, third row second column. So, C 3 2 is equal to 4. So, 4 equal to u 3 plus b 2, okay, and this is u 3 plus b 2 equal to b 2 equal to 6, okay, b 2 equal to 6. So, 6 here. So, this gives you u 3 equal to minus 2. So, we get this minus 2, okay. So, we got the values of b 1, b 2, b 3, okay. B 1 is 6, b 2 is 6, b 1 is 1, b 2 is 6, b 3 is 2, u 1 is 1, u 2 is minus 1, u 3 is minus 2, okay. Now, let us see, we then can write u I plus b j for each unoccupied cell, okay. So, ui plus bj for each unoccupied cell. So, say for example, this is occupied cell, we have allocated 5 units here. Okay. This is unoccupied cell. So, we can allocate this. So, here we will have first row, that is u1 plus b2. Okay. First row, second column. So, u1 plus b2 will be how much? u1 is equal to u1 equal to 1 and b2 equal to 6. So, we will have u1 plus b2 equal to 1 plus 6 equal to 7. So, this will be 7 will be written here, and then in this is also unoccupied cell. So, we have u1 plus b3. Okay. First row, third column. So, u1 plus b3 is equal to u1 is equal to 1, b3 equal to 2. So, we have 1 plus 2 equal to 3. So, 1 plus 2 equal to 3. So, 3 here we shall write. Then in the second row, first column. Okay. So, u2 plus b1. Okay. u2 plus b1, u2 is equal to u2 equal to minus 1 and u2 plus b1, b1 equal to 1. So, minus 1 plus 1 is equal to 0. So, we get minus 1 plus 1 equal to 0. Okay. Then, so this will be 0 here, and then we will have this one. So, u2 plus b2, second row, second column. So, u2 plus b2 is how much? u2 equal to minus 1, b2 equal to 6. So, minus 1 plus 6. So, we have 5. So, we will write 5 here. Now, this is occupied cell, we go to next unoccupied cell. So, u3 plus b1, u3 plus b1. So, what is u3? u3 equal to minus 2 and b1 equal to 1. So, minus 2 plus 1, that is equal to minus 1. Okay. So, minus 2 plus 1. Okay. So, we will get minus 1 here, and then this is occupied cell. Next unoccupied cell is third u3 plus b3. So, u3 plus b3 is how much? u3 equal to minus 2, b3 equal to 2. So, minus 2 plus 2, that is equal to 0. So, we get 0 here, and then this they are all occupied cells. Okay. So, we have got the values of ui plus bj. Okay. So, this ui plus bj we have got, and these are the values. These are the values 7, 3. Okay. This is unoccupied cell, this is unoccupied cell. Okay. This is also unoccupied cell, we have got 0 here. This is also unoccupied cell, we got 5 here. This is unoccupied cell, we got minus 1 here. This is unoccupied cell, we got 0 here. These are all occupied cells. Okay. So, we got the values. Now, we calculate dij equal to Cij minus ui plus bj for each unoccupied cell. Okay. Okay. So, unoccupied cell is this one, this is first unoccupied cell. So, we get D21 or D12. Okay. First row, second column. So, C12 minus U1 plus B2. Okay. And C12 is equal to 7. So, 7 minus 7, which is equal to 0. So, we got 0 here. There is also an occupied cell. So, we take the difference of 4 and 3. Okay. So, D13, first row, third column. So, 4 minus 3 equal to 1. So, we got 1 here, and then here for this cell 3 minus 0 equal to 3. For this cell 3 minus 5 is minus 2. Okay. This is occupied cell. So, we leave it. For this cell which is unoccupied, the difference is 5 minus minus 1. So, 6 here, and this is occupied cell. So, leave it. Then 7 minus 0 is 7. Okay. So, we have got Dij values for all unoccupied cells. Now, let us check their sign. Okay. So, here Dij is 0, here Dij is 1, here it is 3, here it is minus 2, here it is 6, here it is 7. So, there is one Dij which is negative. Okay. If Dij is less than 0 for at least one ij, okay, then the solution obtained is not optimal. Okay. And we have to then proceed further. So, since cell evaluation D22 is equal to minus 2 is less than 0. So, the solution under test is not optimal. Okay. So, what we will do, since minimum Dij is D22 equal to minus 2. So, we give maximum allocation theta to this cell. Okay. maximum allocation theta to this cell from an occupied cell. Okay. Now let us see, let us look at this. Yes. So, we have this minus 2, 8, 2, 10. Okay. So, we take maximum allocation to this cell from an occupied cell. Okay. So, and make the necessary changes in other allocations. Now, what we will do, we have this loop. Okay. So, we make, suppose we make allocation theta to this cell, okay, where d22 is minus 2, then we have to subtract theta from this 2. Okay. It will become 2 minus theta. When it becomes 2 minus theta, total has to be 14 for this fourth source. So, subtracting theta here means we have to add theta to this allocation, that is 10. So, we get 10 plus theta here, and when we have added theta to this 10, we have to subtract theta from this allocation 8. So, we get 8 minus theta. Okay. So, we get theta, if we give theta here, we have to make 2 minus theta here, 10 plus theta, here 8 minus theta, and then we consider minimum allocation containing minus theta. Okay. So, containing minus theta, we have two allocations, 2 minus theta, 8 minus theta. So, minimum of 2 minus theta and 8 minus theta we have to consider, and this is 2 minus theta. Okay. So, we have to put t minus theta equal to 0, minimum allocation is then put is equal to 0, and we get theta equal to 2. So, we get theta equal to 2 means 2 here, and this is 6, this is 0. So, this occupied cell is now becomes 0, and here we get 12. So, this is the modification that we make, and after that what we will do have, this is 5 now. Okay. To this cell theta is 2. So, we get 2 allocation here, and this is 8 minus theta. So, we get 6 here, this becomes 0, this cell allocation becomes 0, here it was 2 and here 10 becomes 12. Okay. So, we get now transportation cost as 5 into 2, okay, 2 into 1, this 2 into 1, yeah, this one 2 into 1. So, 5 into 2, 2 into 1, then 2 into 3, then 7 into 4, then 6 into 1, then 12 into 2. So, we get rupees 76. Okay. So, now we have to check whether this solution that we have got is optimal or not. Okay. So, what we will do, let us proceed again as in step 2, 3, 4. Okay. And what we will do then, proceed in the as in step 2, 3, 4. So, okay. So, 2, what is that step 2? Now, we determine a set of ui and bj such that for each occupied cell rs you see rs equal to ur plus bs. So, let us do that. Okay. So, we come here to this table. Okay. So, allocations we have to see. Okay. First row has got allocation 5. Okay. First row has got allocation 5, second has got allocation 8, third has got allocation 7, and fourth has got allocation 14. Okay. So, total allocation is maximum along the fourth row. Okay. So, take u4 equal to 0. Okay. Let us take u4 equal to 0. Okay. Then as we have done earlier, okay, we have to use urs equal to crs equal to ur plus bs. Okay. So, first let us say which one is the occupied cell. Occupied cell is this one, we are giving 2 here, 12 here. Okay. So, this is fourth row, first column. So, C41, okay, equal to u4 plus b1. Okay. C41 equal to 1. So, 1 equal to u4 is 0 plus b1. So, we get b1 equal to 1. Okay. Then we are giving 12 credit units to fourth row, third column. So, this means C43 equal to 2, okay, u4 plus b3. So, 2 equal to 0 plus b3. So, we get b3 equal to 2. Okay. Now, then we are giving 5 to C11. Okay. So, C11 equal to u1 plus 5. 5 we are giving to cell 11. So, C11 equal to 2. So, 2 equal to u1 plus b1. right. So, B1 equal to 1. Okay. So, this gives U1 equal to 2 minus B1, that is 2 minus 1 equal to 1. Okay. And then we are giving two units to second row second column. Okay. C22. Okay. So, C2 is 3 equal to U2 plus B2. We are giving 6 to second row third column. So, C23 equal to U2 plus B3. Okay. So, what is it? You C23 is equal to 1 equal to U2 plus B3, B3 equal to 2. So, U2 equal to minus 1. When U2 equal to minus 1, B2 equal to since U2 equal to minus 1, we get B2 equal to 4. Okay. Yes. Then we have this one. So, C32 third row second column, C32 equal to 4, U3 is equal to, we have to find U3, B2 equal to 4. So, U3 equal to 0. Okay. So, we have used this one. Okay. And we have used these two also. Have we used fourth row and column 3. Okay, we have used that one also, right. So, now let us find Ui plus Bj for each unoccupied cell. Okay. So, this is unoccupied cell. Okay. So, U1 plus B2. Okay. Because this is it lies in the first row and second column. So, U1 plus B2, U1 is equal to U1 equal to 1. Okay. So, 1 plus B2, B2 is equal to 4. So, 1 plus 4 equal to 5. So, this is 5 here. Okay. Then there is also an occupied cell, it lies in the third row, first row and third column. So, U1 plus B3, U1 is equal to 1 and B3 equal to 2. So, we get 3 here. Okay. Then here second row first column. So, U2 plus B1, U2 is equal to minus 1. Okay. And B1 equal to 1. So, we get 0. So, this is 0 here, and this is occupied column, this is occupied cell, this is also occupied cell, this is unoccupied cell. So, we have here third row first column. Okay. So, U3 plus B1, U3 is equal to 0. Okay. And B1 is equal to 1. So, we get 1 here. Okay. This is occupied cell, here we have third row and third column. So, U3 plus B3, U3 equal to 0, B3 equal to 2. So, that gives you 2 here. Now, this is occupied cell, this is unoccupied cell. So, fourth row and second column. So, U4 plus B2, U4 is equal to 0. Okay, U4 equal to 0, B2 equal to 4. So, we get 4. So, this is 4. Okay. Now, so we have got the Ui plus Bj for all unoccupied cells. Let us find Dij. Okay. So, Dij equal to Uij minus Ui plus Bj for all unoccupied cells. So, here you see 7 minus 5 is 2. Okay. 4 minus 3 is 1. Here we get 3 minus 0 3. Here we get 5 minus 1 4, 7 minus 2 5, and 6 minus 4 2. So, we can see this is 2, this is 1, this is 3, this is 4, okay, this is 5, this is 2. So, Dij is greater than 0 for all I and j which are unoccupied cells. Okay. So, Dij is greater than 0, okay, and therefore, BFS shown by the table in step 8, okay, this BFS is an optimal solution, okay, which is also unique, and total transportation cost we can find. Total transportation cost is 5 into 2, okay, because we are only getting 5 here, and cost is 2, 5 into 2, and then we have 2 into 3, okay, 2 into 3, 6 into 1, and then we have 7 into 4, okay, and then we have 2 into 1, and then 12 into 2. So, this is 24 plus 2 26, 26 and 28 54, 54 plus 6 60, 60 plus 10 70, 70 plus 6 is 76. Okay. So, this is the total transportation cost. So, this is how we can use this Modi's method to get the optimal solution to the problem, where we have already found the initial feasible solution by the BM method, and then we can find the Dij at each step. As soon as we get Dij's to be positive for all unoccupied cells, we get the optimal solution to the problem. So, that is all in this lecture. Thank you very much for your attention.